All right, let's talk about the invisible architecture that runs our world. Data collection, specifically in engineering. It is, without a doubt, the master blueprint behind every single piece of tech you touch. So, let's dive right in.
You know the feeling, right? You see a new product, it looks amazing, it has all the bells and whistles, but then it just fails to connect with people. It's a total dud in the real world. So what went wrong? What's the missing piece of that puzzle?
Well, 9 times out of 10, here's your culprit. It's not the marketing, it's not a lack of talent, it's the data. Or more specifically, bad data. Think about it. If the very foundation of your project is cracked, the whole thing is just doomed to crumble. It really is that simple.
Every single great engineering project, whether it's a bridge or an app, has to start with a rock-solid foundation. But we're not talking about concrete and rebar here. We're talking about high-quality, reliable data. That's ground zero. And this quote just hits the nail on the head. It's the golden rule. You can have the most brilliant design, the most advanced algorithm, but it's only ever going to be as good as the data you feed it. You've heard the saying, right? Garbage in, garbage out. It's absolutely true. So what exactly makes data good? Well, you can think of it as having three main pillars. First up, is it reliable? Meaning, if you measure the exact same thing again, are you going to get the same result? Then, is it valid? Are you actually measuring the thing you think you're measuring? And finally, is it precise? Is the level of detail good enough for you to make a smart decision? You need all three. Okay, so we've got our foundation of quality, but what are the actual building materials? In the world of engineering, our raw material is data, and that data really comes in two main flavors, each one serving a totally different purpose. First, you've got quantitative data. This is the world of hard numbers, things you can measure, count, and stick on a chart. It's objective, it tells you the what, the how much, and the how many. And this is where quantitative data is king. Is the circuit performing correctly? Let's measure the voltage. Is the network fast enough? Let's check the latency in milliseconds. These numbers don't have opinions. They give you cold, hard, objective facts. But, numbers don't tell the whole story, do they? For that, you need the other side of the coin, qualitative data. This is all about the why behind the what. It's about context, experience, and observation. This is where the human element is so crucial. Your app might be lightning fast. That's a quantitative fact. But if users find it confusing and frustrating, it's still a failure. Watching how people actually use your product, listening to their feedback, that's collecting qualitative data. And that is how you build things people truly love. So you see, it's not one or the other. You really need both. You need the numbers to tell you what is happening, and you need the descriptive story to tell you why it's happening. The best engineering projects masterfully weave these two together. Okay, so we know we need these two types of data. The next logical question is, where do we get them? Well, there are two main paths you can take. You can either go out and collect it yourself, or you can use data that's already out there. The first path is collecting primary data. This is where you roll up your sleeves and get your hands dirty. It's brand new, original data that you collect for your specific project, for your specific question. You're the one on the front lines making the discoveries. Here's a perfect everyday example. You've just built a new circuit prototype. You hook up your instruments and start taking readings of how much power it's drawing. That measurement? That's fresh primary data that you collected yourself. But hey, why reinvent the wheel if you don't have to, right? That's where secondary data is a lifesaver. This is data that someone else has already collected and published. We're talking research papers, public databases, government reports. It's a gold mine of information. Think about this. You've built a groundbreaking new machine learning model. Instead of spending a year building a massive data set to test it on, you can just download a standard published benchmark dataset and see how your model stacks up against the competition. That's the power of secondary data. So let's recap. We've got our data types, quantitative and qualitative. We know our sources, primary and secondary. Now, how do we actually collect it? What are the tools in the engineer's toolkit? Well, it really boils down to two fundamental methods. You can think of it like this. You can either be a scientist in a lab or a detective at a crime scene. With the experimental method, you're the scientist. You're actively changing things, manipulating variables to see what happens. But with the observational method, you're the detective. You're just watching, measuring what's happening naturally, without interfering. Both are incredibly powerful tools.
And now we've arrived at the main event. We've talked about the what, the why, and the how of data. It's time to put it all together into an actionable plan. This is the blueprint for success, a 6-step plan for getting your data collection right every single time. This is your roadmap. Step 1, you have to define your objective. What are you actually trying to figure out? Be specific. Step 2, identify your variables. What are you measuring? What are you controlling? Step 3, pick your method. Are you going to experiment or observe? Step 4, choose your tools and make sure they're calibrated correctly. Step 5, plan your sampling. How much data do you need and when should you collect it? And finally, step 6, and this one is absolutely non-negotiable, ensure quality and ethics. Verify your data and handle it responsibly. And this is why having that plan is so critical. This blueprint, it's not just about being organized. It's about getting results that are solid, results that are reliable, that someone else can repeat, and that are ethically sound. It's what separates good engineering from great engineering.
So I'll leave you with this question to chew on. Our world is literally built on data. The next time you use your phone, drive your car, or use any piece of technology, just take a second to think about the invisible web of data that's shaping that experience. And ask yourself, is it good data? Because as we've seen, the answer to that question changes absolutely everything. Thanks for watching.